My name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about how we sketch graphs of the form y is equal to a modulus of x plus b. Right. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. So, like I said, we're going to talk about how we sketch linear graphs of the form y is equal to a modulus of x plus b. So to do this, we need to use the knowledge that we know when we talk about transformations, the translations, the stretches, right? So first of all, let's study what happens with the graphs of these two. First of all, we need to come up with a sketch for y is equal to modulus of 2x minus 4. Then secondly, we need to come up with a sketch for y is equal to 2 modulus of x minus 4. So of course, for y is equal to modulus of 2x minus 4, we need to come up with the graph for y is equal to 2x minus 4. So first, says that this is the y-axis, this is the x-axis, then we've got a 0 there. We're saying when x is equal to 0, y is equal to minus 4. So we've got a minus 4 there. And when y is 0, x is equal to 2. So we've got a 2 somewhere there. Right, says that this would be like that. This is for y is equal to 2x minus 4. And we say that since this is the modulus of 2x minus 4, we only want the magnitude, which is the positive. So we shall reflect the part of f of x that is less than 0. In other words, that is below the x-axis in the y-axis. So we reflect this, then it will be like this. So this for y, so this for y is equal to minus 2x minus 4. So in other words, this will be the graph for y is equal to the modulus of 2x minus 4. And as well, this was just for demonstration's sake, but in actual fact, this won't be there. If we were to consider the final result, and then this we can just put it like this, right? So this is what we have. Now let's look at how we would sketch the graph of y is equal to 2 modulus of x minus 4, right? So in steps, to do this in steps, this is the x and this is the y, right? We shall come up with the graph of y is equal to the modulus of x first. So y is equal to the modulus of x. Sorry, it will be like this, right? Y is equal to the modulus of x. Then to come up with, if we now stretch it by a factor of 2, now becomes this, stretched, it will be like this, then like that. So this now for y is equal to 2 modulus of x. And then if we translate it by a vector of 0 minus 4, in other words, we are moving it or shifting it 4 units downwards, right? We see that we'll get, if this is the 0, so we get to minus 4, we get to minus 4 here, then of course, it will be like that, then like that. But we also need these 2 points of intersection. So this is when y is 0. So when y is 0, solving for x here, we've got 0 is equal to 2 modulus of x minus 4. Then 2 modulus of x is equal to 4 modulus of x is equal to 2, which implies that x is equal to plus or minus 2. So this definitely minus 2, and this will be 2. Right, so this is now the graph for y is equal to 2 modulus of x minus 4. So this is how we sketch the graph. Now I'd like to sketch those graphs, right, for part A, B, C, and D. So allow me to erase this part here. Okay, so for the first one, we need to come up with the sketch for y is equal to the modulus of x plus 1, which we say, first of all, we can just come up with the sketch for y is equal to x plus 1. So there's the y, and then there's the x, there's the 0 there. So when x is equal to 0, y is equal to 1. So we've got a 1 there. And when y is equal to 0, x is equal to minus 1. So you've got minus 1 here. Right, minus 1. Like this. Such that the sketch will be like this. And of course, knowing that we need to deflect the part, we need to put this properly here. So this like that. And we say our 1 is. So knowing that we need to deflect the part, this is the modulus, we need to deflect the part that will continue here. We can just deflect it like that. So this for y is equal to the modulus of x plus 1. Right, such that we won't have to even continue here. Right. And then now let's move on to look at part B. Part B requires us to come up with a sketch for y is equal to 2 modulus of x minus 2. So doing this as steps, if you first of all come up with the graph for, so if you first come up with the graph for this one x0, then you come up with the graph for y is equal to the modulus of x. This will be like this, then like that. So y is equal to the modulus of x. Then if we stretch it by a factor of 2, now it becomes this. D and D. So this now y is equal to 2 modulus of x. And then if we now translate it by a factor of 0, 0 minus 2, in other words, we are shifting it 2 units downwards, we'll come to minus 2, right? We'll come to minus 2, let's say minus 2 is somewhere here, right? And of course, this being what? This being like that. The final graph that we want will be like this, then like this. Right. So this is for y is equal to 2 modulus of x minus 2. But we also need these 2 points of intersection with the x-axis. This is when y is equal to 0. So we're saying 2 modulus of x is equal to 2. Then modulus of x is equal to 1, which implies that x is plus or minus 1. So this point will be minus 1. This point will be 1. So this is how we come up with the sketch for part B. Now let's look at part C. So I shall erase this. Right, part C requires us to come up with the sketch for y is equal to 3 modulus of x plus 2. Right, so coming up with the graph of y is equal to modulus of x, we've got this and that, right? And then if we stretch it by a factor of 3, we've got this, then that. So y is equal to 3 modulus of x. Then now if you translate it by a factor of 0, 2, in other words, we are moving it 2 units upwards. So it means, let me make this continuous here. So it means we've got this continuous. So if this is 0, let's say we've got a 2 somewhere there, right? Means it will be something like this. Let me put this in red. So it will be something like this. Then like that. So this will be now for y is equal to 3 modulus of x plus 2. Right? This is how we come up with the sketch. And then now for part D we need to come up with the sketch for y is equal to 3 minus the modulus of x. In first step, we say if we were to come up with the sketch for y is equal to the modulus of x, this is the y-axis, x-axis, right? So y is equal to the modulus of x, will be like this, right? Y is equal to the modulus of x, this is the 0 there. And then now, if we stretch it by a factor of minus 1, because remember this is minus the modulus of x, we've got this is what happens, we've got this, and that. So this now for y is equal to minus modulus of x, right? Such that if we now translate it by a factor of 0.3. In other words, you're moving it 3 units upwards. We get to say our 3 is somewhere here. Let's see our 3 is here. Right, we have something like this, then like that. And this will be for y is equal to 3 minus the modulus of 8. So the one in blue will be the final sketch that we need. And this is how we sketch linear graphs of the form y is equal to a modulus of x plus b. Please make sure that if you're new to my channel, you don't forget to subscribe, and feel free to leave a comment, drop a like, and don't forget to share. Thank you.